A parallel combination of capacitors are shown in this figure. As you can see, that each plate of capacitors is connected to one terminal of the battery, and the other plates are connected to the other terminal of the battery. Since they are connected in parallel, we can say that the voltage on each capacitor, they are the same. So U1 equals U2 is also the same as U3. However, the charges on each capacitor might be different because these capacitors have different capacitances, right? So that's why Q1, the charge on the first capacitor is just C1 multiplied U1, and the charge on the second capacitor, it is just C2 multiplied U2, and Q3 it's just C3 multiplied U3. This combination of capacitors act as a single equivalent capacitor, and the capacitance of that capacitor, let's denote it with Cp, as you can see in the next figure, and the voltage across this equivalent capacitor is again just U. So this voltage is the same as U1, and it is also the same as U2 and U3. And let's say that the total charge on this equivalent capacitor, let's denote it with the letter Q, and it's just the capacitance of this equivalent capacitor, which is Cp, multiplied the voltage across its plates, which is just U, right? And this total charge, Q, is the sum of individual charges on each capacitor. So it is just Q1 plus Q2 plus Q3. Now let's substitute Cp multiplied U instead of Q, and the other ones, they are just C1 U1. Since U1 is the same as U, let's just write U plus C2 multiplied U plus C3 multiplied U. Cancelling the voltage, we get that the total capacitance of these three capacitors, this is just the sum of individual capacitances, right? C1 plus C2 plus C3. Okay, so this formula can be generalized to any number of capacitors. For example, consider there are n capacitors. Connected in parallel. Then the total capacitance Cp is the sum of individual capacitances of capacitors, okay? So Cn. So this is the general formula.